So today we're going to be messing with this Heathkit model O-11 oscilloscope. I picked it up for $25 at the last Jacksonville Steam Festival at the flea market. And the only thing that I see that's bad on it is the plug. I decided to take off the outer casing just so we can see the circuitry inside. Then we'll plug it in. Of course, later on I'll replace this plug because it's cracked. But for now I can just kind of wheedle it into the power plug and turn on the power just to test it. But let's work on getting this open for now. Inside the case, it's actually pretty clean. Just a little bit of dust at the bottom. That'd be super easy to clean out. Just wish you a little paper towel. Huh. What the hell? Guess this is an extra one? Weird. I was just sitting there. This thing is so huge. I love it. Grab a napkin. Look at that, all the lines in it. All the stuff looks really nice. Has a lot of tubes in it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like only 9. 10. So there's 10 tubes. And I no doubt have spare tubes if some of these are burnt out. It's a really simple design. Power supply down here. The bottom of the circuit board. So here's our vertical input and our horizontal input. I'm really glad that this is like the new banana plugs, much like my power supply, so I can use my power supply leads on this oscilloscope. They're a bit loose, but oh well. Still much better than the other older oscilloscopes I have. Everything down here looks pretty good. I mean, it's really simple and really rugged made. These capacitors back here are 1600 volts, and they look kind of odd. Looks like 0.1 microfarads. I said let's turn it on, and we'll see which valves or which electron tubes don't light up, and we'll just replace the ones that don't light up. Power on. Turn off the main light. Turn off this light. Turn on. Okay, so I see 2 tubes that look like they might be dead. Looks like pretty much all of them are good except for this one and this one. This one and this one, I mean. But I'll let those still warm up a little bit because who knows, might just be a little bit old and take a little bit to warm up. Whoa. What the hell? That's not good. Did the power supply blow up? So I have good news. The reason why I didn't turn on was because the fuse blew. This is a 3 watt 120 volt fuse. Unfortunately, I think the tube may be the cause, and I can't find another tube. It's a 6X4. I'm looking through pretty much all my tubes, and I'm having a hard time finding any ones that would even work. So I may have to fudge it, where I get a different tube that does something similar, and just solder the pins up so it works okay. Or I can figure out what this actually does. That way I can just replace it with transistors if I can. This is the tube that blew, and I'm thinking that it might just have to do something with power, which in that case I might be able to switch it out with just a couple MOSFETs or something. Let's track where the power goes in though. So this is the positive and negative, or this is the AC current coming in. It goes through the fuse, so it's these two wires. Then this wire goes into the transformer. This one goes through here, up to the front, to the switch, and then back through this one, which goes through that black wire. So both these wires are the AC power. Just one of them is switched. That goes in there. Now I'm thinking that, so there's power coming from here. This looks like it's just working as a diode because there's only 3 pins hooked up. This is a 1V2 RCA tube. I'll look that up. Then down here we have we have a green set of wire coming out. We have 1, 2, 3, 4, 5 wires coming out here. Now these green wires come out and they go to the filament connectors on this tube. So the green wire is the filament voltage. So I'll probably try to turn it on and check the voltage on this and make sure this doesn't go too high, because there is a chance that maybe this transformer is shot and so it put the voltage up too high, or perhaps this tube just was getting near the end of its life and it shorted out. I hope it's just the tube that was bad. Okay, so now the multimeter is on the voltage setting and it's connected up to the filament. The filament should get 7 volts of power. If this was getting more than 7 volts of power, like maybe 20 volts or so, that means that this power supply is bad. But if it doesn't go above 7 volts, then that means that it was just that tube that was bad. So just replacing that tube, which would be a $5 part, would fix the oscilloscope. So let's turn it on. Ah, it's AC, okay. You know, to be honest, that looks perfect, because actually I think the datasheet called for 6.5 volts, and 6.75, that's, whenever you're going to have a load on it, that'll go down just a little bit. Maybe it was 6.2, but oh well. It's still well within voltage range. We'll let that heat up for a little bit, because it took like, what, 3 or 4 minutes for the other tube to blow up? But yeah, it looks like it might have just been that. I'm wondering if I might want to check the other voltages though, because you see, like, this pin, the one with the black wire on it, is capable of holding up to 70 volts, which I don't know if I'd put some more than 70 volts through there. Chances are it was just this that was going bad. I just wish I had a good replacement tube for this. Turns out that is a rectifier. It helps to rectify the AC current to DC. A lot of these tubes aren't lighting up. That one is though. But that's because it didn't have the DC current from that tube. So I think we should just see about getting a 6X4, and that should be good. Well, it's kind of a shame that this didn't work right off the bat, but oh well. I really wish I would have had the tube for that. I would have figured with all the tubes I had, I would have had a tube to replace that, but oh well. I'll go and order a tube, and I'll pick up a bunch of these 120 volt 3 amp fuses to have spares, because they'd be nice to have around. And then we'll make a part 2, I guess. Well, anyway, hope you guys enjoyed this video, and thanks for watching. See ya!